Hey everyone, welcome back to Codezilla in our Level Up series. So we have successfully completed our day 9, I think so, because in the previous video I forgot the day actually and I said day 8, but previous day it was day 9. And today we are in our day 10 of Level Up series and today we will be going to solve another problem solving statement. Although, as I have told you in the beginning, we will be solving some of the conceptual problems or the terminology based problems, and today is one of those. You might have heard, or for sure, you have heard about the prime numbers. So, today we will be solving a problem which is related to that only. So, now let me show you the problem statement and then we can start off. So, the problem which we have is like if we got a number n, so what we have to do is we have to find sum of all prime numbers till that number n. So let's firstly take a screenshot and then let's get started. So our traditional way, taking a screenshot, going in our, pasting it here, and then let's start off. So first of all, we will be having input as n. So let me write that input will be as n. Along with that, if our n is 10, by the way, so what we have to do is we have to start finding the prime numbers till the n and summing all of them. Okay. So if 10 is the case, if 10 is the case, so let's find the prime numbers. So firstly, let me tell you brief about that prime numbers. You for sure you have encountered prime numbers in your mathematic journey or while studying in the school, but still it's my duty to tell it. So prime number are the numbers which are divisible by themselves or uh, or we can say divisible by one only. Primes are those numbers which are divisible by either one or either by themselves only. So these are the prime numbers, and composite are directly opposite of it, which are divisible by any other number other than these. So now let's find out. So if we have to start from the beginning only, like 0 and 1, these are not prime, not composite. Okay, so leave these. We will be starting off with the 2. So firstly, let's start off with the 2. Let's see if we can divide it by any other number other than 1 and the number itself. So we can divide it by 1, we can divide it by 2, but 2 is the number itself, and 1 we have already said number divisible by 1, it will be prime only. So there is no any other number, so we will say it is a prime. Come up with 3, okay, it will be divisible by, so if I have to take for the 10 only, if our n is equals to 10, in that case, what will happen? If our n is equals to, in first case, n is equals to 1, we will not take n is equals to 2. We have already discussed it will be divisible by 1 and 2 only, so it will also be a prime number. Now, let's go to n equals to 3. N equals to 3, it is divisible by 1. Okay, it is not divisible by 2. It is divisible by 3, by the way. So it is also a prime number. N is equals to 4. It is divisible by 1. Okay, but it is also divisible by 2. It is not divisible by 3, but it is divisible by 4. So there are three numbers, okay, in which 1 and 4 are 1 and number itself, but 2 is an additional number. So it is not prime. Now, next comes up our n is equals to 5. It is divisible by 1, divisible by 2, no. Divisible by 3, no. Divisible by 4, no. Divisible by 5, yes. So it is also a prime. N equals to 6, divisible by 1, 2, 3, 6, not prime. N equals to 7, 1, and 7, so prime. N equals to 8, divisible by 1, 2, 4, and 8, not prime. N equals to 9, it will be divisible by 1, 3. 9, not prime, n equals to 10, 1, 2, 5, 10, not prime. So we have filtered out which of these numbers are prime, which of these are not prime. Now let's add them according to the problem statement. So 2 plus 3 plus 5 plus 7. And what we will get from here is 17 as the answer. That's what we have to return on. Okay, so we have got what is prime, how to find, and what the problem statement is. Now, if I have to tell you the intuition or the logic behind finding a prime, so you can get from here is in any of the cases, uh, every time we have to check for the prime till half of its length only. Like if we have to check whether uh, 18 is a prime or not, what we have to do is we have to divide 18 by 2. We will get 9. We have to check till 9 only, like number from 2 to 9, if any number divides 18 or not. Because if we go above 9, then there is no number which can divide it. Just telling this also in exemplar form. If we take n is equals to 18, and we have to check if this number is a prime or a not. So for the prime, it needs to be divisible. Now, if we just apply a basic logic here, then what we can say is if our n by 2, we have to check from 2 to n by 2 whether it is whether any number is dividing it or not. Like n is 18, so I will write 18 divided by 2, 9. So if we have to check whether 18 is a prime or not a prime, we have to check it by checking it if any number from 2 to 9 divide divides this number completely or not. And for checking like whether a number divides it completely or not, there is operation called modulo. So if we do like 18 modulo 2, then 18 modulo 3, so what it will do is it will give us the remainder of it. So if we divide 18 by 2, we can get like in 9 we will get 18 and it will be equals to 0. So if this comes up, it comes out to be 0, then we can say it is a prime answer. So that's how we can check off for a prime. Now let's get started with the problem statement and the solution for it. So this is the online compiler in the Calvium module. It is done. I will be pasting the link of this question. So here we can solve it off. It have the basic setup only, like nothing complex like online competitive compiler. So now let's get started. So firstly, there will be input. So int a and taking c in of a. After that, I have to take another one. So firstly, let me increase the size of it. Yeah. And after that, I will be taking int sum, which will be equals to 0 at the beginning to find the sum of each of them. For loop int I equals to 0, I less than a I plus plus. Okay, so now what happens whenever I write a for loop, I directly write the for loop and then think about it like whether it is needed or not. So it is actually going to be 2 and it is going to be equals to. So why it is? So we will be checking from the for the numbers, we will be checking it for the cases in which it is like if what we have to return by the way, we have to return the sum only now, yeah. So as I have said, prime number starts with 2 and we have to go till the end of that. So we will be checking in that way to find all the primes. So now let's get started because 0 and 1 both are not prime numbers. Yeah, both the numbers 0 and 1 are not prime numbers, so we will not consider or we will not check for that number. Now, what this for loop will do is the question statement which we have till 10, we have to find all the prime numbers. So till a means till 10. From 2 to 10, we have to find whether which of those numbers are prime. So for checking that, we have to make a function. We have to make a function which is prime if condition is prime in which we will send off this number, in which we will what we will do, we will write I, and if this returns okay true, then we will do total plus equals to I. Simple. Now we have to make a function is prime. So it will be a Boolean function for sure. We have to just tell whether this number which we have got is a prime or not. So I will write is prime, taking input A, and if our okay, we are not considering that condition. So if we get 1 or 0, we already have to return 0 only, which is already written. So we have to directly start off with the loop. So what I have told you in the intuition only, or in the logic behind this problem, int I equals to 0 for sure, not for sure, because we will be starting here also checking like whether is this number which we have to check is a prime or not. We have to check it from 2 till the n by 2, means 2 till the a divided by 2, and then doing I plus plus. That's how it will work. We have to check till the half of it only. Now, if if our any of the number divides it, we have to directly return false. Otherwise, we have to go till the end and return the true. If now we will be applying that modulo operation, which I have told you in the intuition, I think. So now, if our a modulo, sorry, a modulo I comes out to be 0, if a modulo I comes out to be 0, in that case, what we have to do is, it means like it have divided that number. Then we will return, then we will directly return false. And how these function works is, once we return something from it, like is prime, if we return any value, it will be gone. Then it will not execute further. Then after that we will return true, and that's how it will work. Now, if we go here, we can just see out the total, and let's check this off. If there is some issues, we will see them. Yeah, because total, I have never written total. It is actually sum. So these things happens a lot with me specifically. I have written sum here, but here I have written total. Yeah, so it is passing some of the test cases, but for some it is not passing off. Now let's find the edge case which we might have. Now the edge case is if our the number which we have got is actually 0 or 1. In that case, if if our if we can say if our a is equals to, or let's write it at the end only, if our a was equals to 0, or we can write if our a is equals to 1, in that case we have to do C out of, in that case we have to do C out, but we have to return 0, else C out of sum. Now let's run out the test cases to see if it works or not. Mhm. So that's how this whole thing is working. Still, we are not able to pass some of the test cases. We might got some edge cases. Now let's figure out what those edge cases might be. Starting off with I equals to 0, going till the end. And by the way, this is causing error or issues. No, that one is the perfect. Okay, now let's check this again. Yeah, these are passing off, but the fifth test case and the eighth test case is not running properly. So let's read the problem statement also. Write a program to give sum of all the prime numbers till n is 10, then sum will be this. Okay, for 20 it will be 77. That is also working fine. So now let's check it, checking from the starting only. If we take the sum is 0, we check if that number which we have got is prime or not. Is it something like we have to go till the last because limits are sometimes not cleared to us? Yeah, that is the issue. So what was the issue you have to figure out? Now in the question it was not that much clear to us, like whether the number we have to go till the number or that number is also included. So that's the issue. Because like what I like want to tell you properly is I don't solve the problems before recording the video or doing something. Whatever I have in my mind, I just open the question. I have a sort of questions which I have thought I will be doing these. So I don't solve those questions. So whenever I encounter a problem, so right now, as you can see, I encountered one of the problems. So what I did is instead of just going or making a new video in which I told everything from the basic and everything works very fine. It is not like everything will work totally fine when you will be solving any of the questions. So that's how it works. I thought about some of the edge cases, cover up those edge cases. After that, read the problem statement. Still in the problem statement, you can see write a program to give the sum of uh, till n. So I don't know till means it is like 10 tak or 10 is also included. Suppose n is 10, so here is nothing like that, right? So these things work. So you need to learn these things, how to figure it out, how to solve it off, and that's how like just like completing off or just removing that equal to sign b goes till the a till less than a, and that's how it works. So here our all test cases got passed, and we got the intuition also, like how we are checking for the prime number, how this for loop is working off, and how we are returning off or we are printing off the sum. So that's how it works. If you encounter any of the problems, comment it. Otherwise, try to solve it by yourself only. It is the best practice. I also encountered problem while recording this video. So I didn't thought of, okay, I have got a problem, my test cases are not running, so I will cancel off or I will remove this video and then record another one in which I will do this solution perfectly. Perfection never comes like this. So that's all for the video. So thanks for watching.